Hello everybody, my name is Mitch Steinsberger and I'm with IBM Integration. In this video, we will be giving you an overview of the Cloud Pak for integration and diving into the tracing capability to show you how you can get full end-to-end visibility into your integration workflows. The Cloud Pak for integration is a one-stop shop for all your integration needs and architectural styles. It includes different capabilities such as API lifecycle management, app and data integration, enterprise messaging, high-speed data transfer, all on top of IBM's internal and external gateway. IBM has recently partnered with Confluent, the original co-founders of Apache Kafka, to provide enterprise-ready event streaming to your applications. All this software is deployed as containers running on Red Hat OpenShift. Red Hat OpenShift is platform agnostic and runs on any of your existing infrastructure, whether that be IBM Cloud, another leading cloud provider, or on your on-premise database. Now meet the hero of our story, Julia. Julia is an integration administrator for Acme Company. She works hard every day to make sure all of her integration applications and workflows are running smoothly and efficiently, to make sure Acme's systems are running properly and customers are happy with their services. Julia's most important application to monitor is her invoicing application. Here is a breakdown of how this application works. First, a user makes a request on Acme's website using their smartphone. The request is sent as a JSON packet that travels to Acme's API gateway that provides security to their APIs. Once through, the underlying integration flow is invoked and the request is sent as a message for back-end processing. One day, Julia wakes up to an early morning call from her boss, Jerry. Jerry sounds nervous over the phone. He tells Julia that there's an issue with the invoicing application. This invoicing application's latency is through the roof, and Jerry feels that this will negatively impact Acme's customers. He tells her to see what she can do to fix the performance bug right away. Julia, on the other hand, isn't too worried about the situation. She knows exactly where to go to gain visibility into her integration capabilities. She quickly logs on to OpenShift Container Platform to save the day. The first step in Julia's journey to try to debug the invoicing application is pulling up this screen right here, which is called the Platform Navigator. The Platform Navigator is a central home base for all of the different automation capabilities that are running on Red Hat OpenShift as containers. More specifically, what's installed now is Cloud Pak for integration components. If we get on the list here, she has different components installed like API lifecycle management to create, manage, and socialize APIs, messaging for once and only once assured delivery of messages, integrations. We have ACE Dashboard, which is a server runtime component that deploys as containers running in Red Hat OpenShift. And then Designer, which is a no-code tool to create integrations for citizen integrators. And then finally, we have the tracing component, which provides end-to-end tracing and visibility into different integration flows. So the first step Julia is going to do is actually test her integration flow to make sure there is performance issues and latency just as Jerry had described previously. So to do that, Julia is going to click on and dive into the API Lifecycle Management tool. When Julia gets the API management screen, she'll dive into her different API options. So here's a list of her different APIs and the different versions associated. And remember, Julia is going to be working with her invoicing application that receives an invoice, creates a message, and sends it to her backend for processing. So she's going to click on the latest version of her invoicing application. And what she sees is a Swagger editor of her API. She'll go into Test. And this test screen is a great and beneficial testing capability built right into API Manager that uses a no-code testing approach. So very, very simple to use here. She'll go into Body and type in really the template of what the invoicing message that will be received, and she'll test against that API gateway component. No, we can already tell that took a long time to process. We have what the message will look like going to our backend, which looks great. And we have the 200 OK response, which is what we want to see. But this response time is 5 seconds, which is way too long for our standards. So we know that there is an issue like Jerry was talking about previously. So what do? We're going to jump back into our platform navigator and go into our tracing component here, which provides the end-to-end tracing of our integration flows. When Julia enters the tracing capability, this is what she will see. She'll see different great metrics in the overview screen, such as new traces and different latency spans correlated with the different capabilities. To get a more detailed view, she'll hop in the traces screen. And this will give a list of all the different traces that have touched our integration components. So we have a lot of traces here, but if we scroll down, we can find the trace that has touched the different components all bundled together, so we know it's reacting with our flow. When we click on this trace, we can see a bird's eye view of our end-to-end integration flow. We have, whenever the application is started, the request is sent, it hits the API gateway. From there, the integration flow is invoked and the message is put on that back end for processing. If we go further into our different layout, we can see the latency as associated with the different root operations and products. So here we have our different capabilities like API Connect for our API management, our App Connect, which is the server component, and an MQ for the messaging. And we can see the sub-processes here as well. So we can see just as easily that this start assembly is taking 5 seconds and is a vast majority of our total duration. So we know that the start assembly in the API management capability is the culprit here. So finally, we can go in and look at our API management screen and see if we can locate a fix for this bug. So if you remember, the start assembly operation was the longest by far. So we'll dive into the assemble screen And looking at this assemble screen, Julia remembers that this XSLT script was just added with the latest version, which is some added features and functions of this invoicing application. So she thinks to test the earlier version that didn't have this XLT script. If we go to assemble here, that latest functionality is not added, so we can test against this version. We'll click on here, which makes the API able to test against. And we'll test against the API gateway here with the same JSON packet as before. And here we go. Great news, our response time is drastically lower. We have the 200 OK response with the same type of JSON message that's sent to our backend, but with a response time that is way, way lower, which is exactly what we wanted to see here. So we think we solved the issue, but we're going to go back to our tracing component to see if it checks out on that end as well. So here we're back on the tracing screen. We're going to find the associated trace. And here we have that bird's eye view once again of our great start to end integration flow. And if we look at the latency durations now, we see a vastly different picture. We have everything about the same here. And if we look at our start assembly, it's 34 milliseconds as opposed to that 5 seconds. So everything checks out here. The different durations are within what we wanted. And we knew that by switching to the versions, we were able to find the culprit and fix the performance issue within our invoicing application. And just like that, the day is saved. Julia managed to find the bug in no time at all. She can now roll back her invoicing application to a previous version and meet with the development team to describe the bug she found so they can look to address it in the next release. With tracing, Julia was able to gain full visibility into her capabilities and pinpoint latency across her integration flows. You can find this capability along with others as part of the Cloud Pak for integration. Thanks everybody for tuning in. Again, my name is Mitch Steinsberger, and it's been a pleasure demoing for you today.